And good morning. We're still in the morning, I think, for a couple of more minutes. It's great to be with you today. This is a topic of big data that a lot has been written about, a lot has been spoken about. You may be tired of the topic a little bit. Nevertheless, we find, at least in my travels, that customers of SASs are underutilizing their data assets. And so today's discussion, what I prepared is a checklist, a field guide of sorts, to help you accelerate your big data efforts or get them off the ground if you haven't started them already. Tried to make this as practical and tangible as I can in 30 minutes time or so. I'll be available for the next day and a half. We'd be happy to talk with you further. The strategies that I'll share with you today talk a lot about technology, as the title indicates, but really from an integration and some of the key considerations we see about new technologies like Hadoop and where they fit in. So a lot of my travels at SAS span 29 years. So I've seen the good and the bad and the ugly associated with large-scale analytics projects. And then over the past 2 years, myself and the enterprise architects on my team that are engaged with many of you in your big data efforts, we see some real key considerations and best practices evolving, and some of those I'd like to boil down and share with you today. We have been, at SAS, that is, participating in this big data analytics market for quite a while. We've earned some high marks in terms of both the products that we put forward, tools that provide analytical capability, and I'll define analytics here shortly, tools that integrate data from a ground up, across the enterprise. And then we have folks that are very adept at integrating existing ecosystem technologies like Hadoop, like existing database technologies, like these newfound appliances that many of you are, I'm sure, reading about or deploying within your enterprise. We're proud of where we stand, and it has given us, again, a sense of what works and what doesn't in this market. A quick set of sort of basic foundation definition slides. What defines big data? Sort of you know it when you see it, and to us, it's really when you go beyond the scope of I'm uncomfortable. And in my travels, it's data volumes, it's variety and velocity, that usual stuff. A lot of times, though, it's skill sets of people. This newfound role of a data scientist. Can you attract them? Can you retain them? How can you put them to work in technology spaces like Hadoop? How can you leverage data out of Hadoop? This is the kind of day-to-day project work we're doing at SAS. But this is sort of how we define it, simply put. The challenge, as we see it, is how to derive value from the data. And so much of my talk today will be about how do you drive out relevant data from this pile of unstructured data, web logs, set-top device data, financial data of every shape and size, the text survey information that comes in, whether it's driven from sentiment analysis projects and the like. We see that SAS can play a key role in driving down that overload of data into what's relevant. Just last week, I was engaged with a financial services account that was looking to leverage between 10,000 and 35,000 columns of data within a predictive modeling application. When you consider that database technologies like Greenplum and Teradata and Oracle can support only between 1,000 and 2,000 columns of data, now we're looking at 35,000 columns of data for the purpose of predicting home loan defaults, for example. That's a ton of data. Our role is to drive out what's relevant among those columns. So how can we, boil out what's really important to predicting home loan defaults, for example? And that was a case of looking at an integration between SAS and Hadoop, because Hadoop's the only data store that can support that kind of very wide table. I promised I'd get some of the definitions out of the way. We think the marketplace, and in particular the vendor community, has done a great job or a poor job of dumbing down what analytics are all about. In my 29 years at SAS, this is how we define analytics. So keep these bullets in mind in terms of predictive modeling. Who will attrite? Who will be fraudulent? Who will be at anti-money laundering risk and the like? So that's how we define it. There's been a great uptick in terms of predictive analytics as the source of differentiation and competitive advantage. This came out of Accenture Analytics just a short while ago. So huge uplift in terms of the role of predictive analytics to help drive differentiation. And then lastly, this framework slide, and then we're going to move into this field guide, as I called it. We think the heart of the matter is exploiting or accelerating this analytics lifecycle, involving the preparation of data for the purpose of analytics. You know, our school of thought at SAS is start with the end in mind. What's the business problem that you're trying to tackle? What analytics are relevant to that topic? And what data requirements need to feed that analytic process? So preparing data, whether it's in Teradata, DB2, Oracle, all the above, and more recently now Hadoop, and you'll see the role of Hadoop in a SAS context here in a minute. How can we explore or visualize, as the very popular term these days in the technology space, how can we visualize that data? How can we then downstream have our statisticians do predictive modeling, for example? How do we operationalize those models in a model deployment and a model monitoring phase? So it's my belief, as part of, before we head into this field guide of practical considerations, it's your ability to execute this more quickly or with more accuracy that can provide that competitive advantage. So this is all a precursor to really the heart of the matter today, and what I've tried to take in my time at SAS and boil down into 30 minutes is this set of practical considerations. I promise it won't be a product overview and a ton of marketing speak. Really, this is kind of up-leveled from a SAS context into key technology areas that you ought to consider as you look again to accelerate or launch your big data analytics efforts. First point, and we're going to go through these sort of section by section. First off, we're going to talk about how can you design a flexible analytics architecture that meet the requirements both of IT and of the business community. And for many of you, you know that's a real challenge. I heard a senior business executive a week ago tell me, Paul, governance is just another word for IT to tell me no, just to tell me no. Like, wait a minute, that's a little harsh. But truly, we do want to manage data and govern it for the IT folks while delivering the agility, the transparency of data for the purpose of business analytics and predictive modeling. So that's number one. Number two is I see a real opportunity to take what we've done for many years and what other companies perhaps have done for many years in the analytics realm and move analytics well upstream of where it's traditionally been deployed. Analytics for so many years during my time at SAS, and SAS started just a handful of years before I joined as really a startup company, analytics were for the domain of the statistician, the domain of people that were locked in a room, took data from their buddies in the business community and did some magic to it. Well, those days are quickly changing, and the notion of approachable analytics is really where this data scientist role comes in. How can we find a needle in a haystack without being as reliant upon IT and the statistician community? But we see an interesting way to leverage analytics upstream, so more on that later. In-database analytics has been around for a while. Folks on my team and myself, we pioneered a lot of that work back in 2007 with Teradata when we deployed the first ever technology inside a database to minimize data movement, redundancy, and really to leverage this kind of MPP architecture that is Teradata. We've extended that to include now in-memory visualization, in-memory analytics. Other vendors are operating in this space as well, but we see tremendous opportunity to better execute a big data analytics strategy by leveraging these new in-memory appliances, and you'll hear more on that here shortly. And then, okay, that's enough about the technology pieces. The final point from my travels is back to this business and IT conundrum. Business guys want all the data forever. IT doesn't want to give them all data forever. So how do you align forces in terms of meeting the governance requirements of IT while meeting the business needs of the business analysts and data scientists, among others? So there is a sort of a people process component to the checklist, which I'll talk about here in a few minutes. Okay, the first step in our checklist in this field guide is our belief, my belief, that if you have the data on the left-hand side, and this can be data of any shape and size at any velocity, but including unstructured data or multi-structured data, data on the left, the end user community on the right, and the union of IT and business sort of in the middle. We see an ongoing role for enterprise data warehouses. So those guys are not being put out of business by the Hadoop products, commercial or otherwise. So we see an ongoing role for that enterprise data warehouse. But more importantly, in this context of big data analytics, though, we see the emerging deployment of an analytic data warehouse being fed by the EDW, perhaps taking the form, if any of you are familiar with Teradata, they espouse a data lab concept within their kind of a logical space within their enterprise data warehouse. That can certainly be that. As you'll hear, though, in a few minutes, we see that the emergence of these MPP appliances playing a key role to deliver that ADW capability. Or my friends from SAS would agree that we see Hadoop clusters being also the home of that analytic data warehouse, a segment of a broad Hadoop cluster. So more on that later. And speaking of Hadoop, this notion of a data lake, as the marketplace is calling it, I was up at a large media company a couple of weeks ago up in Seattle, and they have all of their data being poured into Hadoop. And then from Hadoop, they make decisions relative to what data warehouse might the data go into as they're trying to drive out what's relevant. This is sort of the all data forever data store. And then downstream is where we begin to fashion more value, back to that wave chart I showed, try to fashion more value, more relevance out of the data as we move left to right. Any questions or comments about this idea? Sort of makes sense? Sure, yes.
In your experience, how many companies actually have this, the ADW as part of the EDW?
You mean
or just as one combined unit?
a data lab within the EDW? Yeah. I would say over half of the Teradata shops, for sure, and would drop off from there, but Teradata really promotes that data lab concept. So, yeah, you bet. Okay, as we move down through our checklist, this notion of upstream analytics, analytics will continue to be the domain of statisticians. We know that. Will continue to be the new domain for these emerging groups of data scientists. I live out in the San Francisco Bay Area, and buddies of mine that are data scientists, I say, hey, what do you do at places like LinkedIn and various other places? And they go, well, I'm really a business analyst, but I'm based in the Bay Area, so I must be a data scientist. Their job profile goes up, hopefully their salary goes up in the whole bit. But in this context, one of the more mundane jobs I have in my family when I'm home is to get the mail each day. So I take a walk, their mailbox is a couple blocks away from our home. So I make that lonely walk to acquire the mail. And probably like many of you or all of you, you kind of sift through the mail on your way back to in your house. Some stuff goes right in the recycle bin. Some goes on the front desk like a tax bill or a 1040 or whatever. And you want to pay attention to that. So you're determining relevance on your way back before you store the data, in essence. So what has been ironic to me in my travels is, we've spent a ton of money, we, the community of IT, have spent a ton of money to store data before we determine relevance. It's back to that relevance, back to that value. So this notion of acquire, store, then analyze doesn't seem to resonate as much anymore in light of the data volumes that we and you are dealing with. So we think there's a better way, and particularly in this big data analytics space. So myself, folks on my team have been deploying a strategy with customers we simply refer to as stream, score, then store. So let's use analytics in a way that makes decisions about where data need to land, makes decisions about the relevance of data way before the time is that we store it. So for example, in comes the data, Twitter feeds, social media data, transaction data of all the, the piles of it that we see. The notion of let's create a model, a predictive model that's based on what our competitors are doing, what's happening in the marketplace today, in the financial markets. Who should we keep an eye on? What technology, what competitor, what product, what economy should we keep an eye on? And let's build that into an analytics model that we integrate in with our information management strategy before the data are stored. Raw relevant data might go into Hadoop cluster. Pick your favorite, Cloudera, Hortonworks, Apache, whatever the case. Higher cost for more relevant data, again back to that word relevant, would find its way into a more expensive data store like a Teradata and others. But this is a notion that we've been popularizing now for about a year and have been working on deploying a number of projects with customers that are trying to get their foot in the water about where does Hadoop fit in. And oh, by the way, I've got a huge investment in IBM, Oracle, Teradata that I want to continue to leverage. And we see a role for both technologies. This is a report that I can't see it, I know you can't see it. But in the pie chart, this is low-cost data, i.e. Hadoop, and this is a report that IT operations would see. Higher cost or high cost, Teradata, for example, or Oracle, for example, is in green. The marketeers amongst us would look at the bar chart on the right. What competitors are we needing to look at? And we want that data right at our fingertips for the purpose of visualization and BI. So operations on this side, but everyone wins is sort of the idea. The marketeers have quick access to information. They don't need to dig through a pile of MapReduce code or contact their buddies that are Python programmers that can dig into Hadoop. They want the data right now. However, they know that the competitors change, economies change, products change, and somewhere at some point, store all data forever might make sense. So let's keep that data around, like some would say a massively parallel tape archive system, which is Hadoop in some cases. So far, so good. 2 checklists down, 2 to go. How are we doing on time? We're okay? Okay, perfect. We're going to spend a bit more time on this idea of real-time visualization and in-memory analytics because that truly is what can put some speed behind this analytics lifecycle. Again, to the extent that we can prepare data more quickly, stage it more quickly for analytics, then visualize it, business analysts, data scientists, then build predictive models, deploy those models more quickly. There's a huge advantage there. I'll share with you in a moment a case study that describes some of the benefits associated with doing this. Setting aside the data lab strategy of the likes of Teradata, setting aside Teradata, for example, and Oracle, and many other products for which we have in-database analytics alive and well, we see huge opportunities to leverage at very low cost, very high ROI, these in-memory appliances, in-memory technologies, and pick your favorite or a combination. Teradata, Greenplum, Netezza, Aster from Teradata. These are the types of technologies that are depicted on the screen. We worked with a financial services company, a large retail bank. Folks on my team, we met with them and we identified a series of use cases that they were really struggling to tackle quickly, trying to put some speed into their analytics lifecycle. And these folks have been using SAS for upwards of 20 years in a variety of areas, in risk management and in their marketing operations. We engaged in a particular project that they steered us to, a logistic regression application that took nearly a week to execute, from the time they hit enter to the time, voila, the analysis was generated. And it was there to predict home loan defaults in the US. So a popular application, in the past several years. What we did was take that existing code, existing data, that exact same problem, and leveraging those MPP architectures, we're able to take that exact same code base and execute it in 84 seconds. Now you say, well, okay, you've recovered, the good part of a week to do it. We saw the opportunity, as they did, that if we could reduce home loan defaults by producing better models more quickly, which now they can run a model, 90 seconds later, change the model, add columns, subtract columns, use SAS to reduce, to do variable selection, to reduce the number of variables that truly predict home loan defaults. But if they would reduce defaults by 1 percentage point, it's tens of millions of dollars. And this wouldn't be the only use case, and they could use this technology for. So huge advantage. They can play the kind of the what-if analysis with their analysts and with their statisticians. Now, how did we do it? And we're going to spend just a few minutes on this. This is my fancy way of up-leveling the conversation without getting down into the weeds. But what we're doing is, in essence, locating the analytics within the Hadoop cluster. So we're co-locating, the analytics to the data. We're not shoveling the data outside of this environment. So IT wins. They get the governance they need. And yet the business user, they launch the application. It goes and executes on an on this cluster, and up comes back the answer in just a few seconds, without moving data, without replicating data, and all that nasty stuff. So this is sort of the math blades at work. I'm sure you've probably heard or read about that term. Spreading the data, spreading the math to these low-cost blades within this environment. This is a very popular strategy at work these days. We have countless customers in financial services approaching us about how do we leverage Hadoop, how do we leverage our existing environment in SAS analytics, and how do we gain the speed of this sort of an MPP architecture and Hadoop? Because everyone, my experience has been 85% of SAS customers of your class have at least put their toe in the water about Hadoop, whether it's a test instance or a large-scale production deployment. And they want to leverage that investment and drive value out of it. And certainly one way to do that, we believe, is deposit the analytics inside of that engine. The alternative approach, the first one was a co-located architecture. The second, excuse me, I have to get this guy to work. The second is a structure that, for whatever reason, we have perhaps an equal number of customers that say, Paul, what I'd really like to do is take the data out of my Hadoop environment or out of my Teradata environment. I'd like to pass it across a high-speed switch into one of these purpose-built appliances. And Teradata has a SAS appliance that does just this. Leverages an existing EDW footprint and doesn't copy the data, but persists the data into the memory of this appliance across their BiNet technology, sort of their proprietary version of InfiniBand. In either case, the math, the data, you create the same benefit, high speed without copying the data. So again, to each his own sort of a thing. We find as many customers and prospects interested in that co-located SAS inside of Hadoop as we do, leveraging this connected appliance strategy. The owner of our company, Jim Goodnight, Dr. Jim Goodnight, strolls around campus these days and talks about billion is the new million. Billion is the new million. You bump into him in the elevator, and this is what he's talking about, because he personally pioneered a lot of this in-memory technology back in the last several years. This is a screenshot I took of our visualization and analytics technology, SAS Visual Analytics. This is the kind of performance that we see, on campus with customers every day. We can scan 1 billion rows of data in a fraction of a second. At the kind of price to performance that these, multi-node blade environments can give us. So whether it's, pick your vendor to supply the appliances, and you can add Dell and HP and Cisco into that mix as well. We think the price and performance is pretty compelling. Okay. I'd urge you to give this a try. We're winding up the presentation here shortly. We had originally staged SAS Visual Analytics up in the Amazon EC2 environment for customers and prospects to poke away at and test drive it using some existing data that we have out there. And we have data across different verticals. We've since brought that in-house, although we're fond of saying, our cloud, your cloud, or their cloud. The fact remains you can go on the SAS website and check this out. It's you can play with the product or have your colleagues take a peek at it and get a handle on what types of things visualization and analytics without being a statistician can do for you. Okay, final checklist item is sort of last but not least, the people process side of things. And for this, I pulled up sort of the survey says, what we have seen to be challenges in adoption, and I could probably change that date from 2011 to 1991, and perhaps true in 10 years' time. Fact remains is there are certain ongoing business and IT challenges. Business guy says, I asked for the data, but I can't get the data. He or she in IT won't give it to me. Then the business folks or the IT folks say, I don't know what they're going to do with it. I know they're going to harm themselves or harm the company. So for governance reasons, I can't give them everything that their little heart desires. And we sit somewhere squarely in the middle, kind of on either side of the aisle, you might say. How we, though, have been addressing this is a best practice that I don't know if we have any Alabama football, basketball, baseball, whatnot fans in the room. We have this assessment we call the BAMA, Business Analytics Maturity Assessment. And it's a on-site workshop. Folks like myself and folks on my team help facilitate between business and IT, but not of the enterprise variety, not at the scope that many of you are operating on behalf of your organization, but very point specific. Call center, marketing, risk, fraud. What can we do to help align the business and IT folks, generate consensus around a set of priorities that both parties can agree to? So we facilitate the conversation, spend a half a day with the IT folks, half a day with the business folks, bring everyone into a room like this one, and generally the numbers aren't more than 15 people combining the two because we're focused on a particular problem. You don't have to rely on us to do this. I'd encourage you and your constituents, whether you're in business or IT, many of you IT I know, sort of take your business buddy to lunch on Wednesday, this kind of thing. The end goal, though, whether we help you or you help yourselves, is to drive more alignment and encourage your folks to work in more collaboratively if there's a need to with the business community. This is one technique that we've been doing probably 5-6 times a month. We do these around nationally, focused on these particular problems. And then lastly, from our experience with that, I'd also steer you to this, much the way I did that cloud site to give our visual analytics product a try, is that we just launched this 2 weeks ago. It was an outcome of the Business Analytics Maturity Assessment. That assessment, that on-site assessment, on our part requires 1 or 2 weeks of preparation because we do a series of pre-work with our customer. We go on site. They have time spent with us, obviously, and then we spend about a week to generate the findings and recommendations. This is not that. This is sort of some quick and dirty insight that you or your colleagues might be able to obtain by going to SAS.com, BA Online, and it gives you a means to sort of do a health check about where you are relative to a variety of analytical dimensions. Empowerment, precision, accuracy, these kinds of things that span both business and IT. And then you get kind of immediate feedback of how do I stack up relative to my peers in my industry. So I'd urge you to check it out, and maybe you can use that as your calling card. If you'd like to work with us, then we can deepen the conversation. Maybe we can even do a couple of these during the course of the meeting over the next day and a half. Last slide, I think we're pretty good on time, is just to give you some food for thought. I'd encourage you to, look at new ways to leverage your existing data and maybe your newfound data in the context of Hadoop from an analytics perspective. Are you truly making hay from this new volume of data that you're probably spending a great deal to integrate within your organization? Are you leveraging this kind of MPP architecture that we find so compelling, at least, that Dr. Goodnight finds so compelling? Very low cost, highly performant environments for the purpose of visualization and analytics. And then finally, we think that the people in the process side is very important too. We want to, if we can, act as the marriage counselor. If the shoe fits in places where business and IT may not be well aligned, we can provide these kind of resources and facilitated discussions to help you drive that. And if you can do it on your own, then absolutely more power to you. We just think that's a key part of this whole strategy of embarking on this big data analytics process.
Okay, thank you very much.
Thank you very much.